This lecture is going to deal with chemical nomenclature, and the goals of this lecture are going to be to learn how to name simple chemical compounds. In addition to this lecture, I'd encourage you to read section 4.3 of the OpenStax textbook. So when we think about compounds, one of the things to keep in mind is, to date, there's over 37 million different compounds known. To cope with this scale of this number of molecules, chemists have devised a systematic naming system that allows us to communicate accurately the chemical formulas of these compounds. There's two main types of compounds, and so two main types of naming systems that we will go over. The first are ionic compounds, and the second one we're going to look at are covalent compounds, and we're going to really look at binary covalent compounds, meaning there's only two different types of atoms in those compounds. And so the first question we need to answer is, how do we know if we're dealing with an ionic compound or a covalent compound? And we can answer that using the periodic table, and we'll start off by talking about naming ionic compounds. So when we think about ionic versus covalent compounds, the main difference between those is when we have an ionic compound, this is going to be when we have a metal and a nonmetal coming together, which will form an ionic bond, and we will use the ionic compound naming system. For a covalent compound, these are when all of the atoms in our molecule are nonmetals. And so what is a metal and what is a nonmetal? We can use the periodic table to help us, and we can see metals are typically referred to as what's shown in this orange color here, the left side of the periodic table, and our nonmetals are the right-hand side of the periodic table and hydrogen. So if all of the atoms are nonmetals, we will use the covalent compound system. If we have a metal and a nonmetal, then we'll use our ionic compound naming system. So when we name our ionic compounds, we can follow a short simple set of steps. We're going to start off and say ionic compounds are formed between metals and nonmetals. The metal will be a cation, and the nonmetal will be an anion. So these are ionic compounds, so they're held together between a force of attraction between a cation and an anion. When we name it, the cation, the positively charged species, is always named first in the elemental name, and then the anion is always second, but we're going to change the ending of the anion to add IDE or "ide" on the end. So we would write something like fluoride, right? The elemental name is fluorine, but if it's an anion, we'll call it fluoride or oxide or chloride. So we're going to end these in IDE. The charges of monatomic ions we can find from the periodic table. So one of the things that's important when we name ionic compounds is what is the charge of the ion. And the periodic table can help us with this. So if we go back to the periodic table, we can remember that the group numbers tell us something about charge. So all the alkali metals in group 1 will always have a positive 1 charge. The alkaline earth metals will always have a positive 2 charge. If we go to the right-hand side of the table, the halogens will always form negative 1 charges. And then we have some other elements that it's helpful to remember. Aluminum always ends up going positive 3 if it's a cation. Zinc always ends up going positive 2 if it's a cation. And then we have the middle of the periodic table, our transition elements. And these can adopt more than 1 charge. So here we see iron with a 2 charge, plus 2. Here iron with a plus 3. And because it can adopt more than 1 charge, we have to actually indicate what the charge is in the written name of the compound by putting that charge in parentheses, and we'll see an example of that in a minute. So here we have 2 examples. We can start off and say, what is the chemical formula for magnesium chloride? So here we're given the written name of our ionic compound, and we know it's an ionic compound because we have a metal and a nonmetal. So if I was going to try and write the chemical formula, the first thing I would do is look up what are the charges of our ions going to be. And so we can look that up from the periodic table and say magnesium is an alkaline earth metal, so it'll always have a positive 2 charge. And chloride will always have a negative 1 charge because that's a halogen. And so when we write our chemical formula, the last thing to keep in mind is our ionic compounds, when they come together, will always overall be neutral. And so we need the total charge of our molecular formula to be 0. And so since we have a positive 2 charge here and a negative 1 charge here, we're actually going to need 2 chlorides to balance out the charge of our magnesium. And so our molecular formula will be MgCl2 with the subscript 2 to show that there's 2 of these chloride anions. We can then look at a second example and say, what is the chemical formula of copper 1 bromide? And here's a case where we have a transition metal, copper. Transition metals can have more than 1 charge, and so in parentheses we can see that charge is specified in brackets. And so again, we're going to break this down and say, let's write out the charges of our ions. And so we'd start off and say copper 1 would have a positive 1 charge, and bromide is a halogen, so it's always a negative 1 charge. And so since we have a +1 and a -1, we'd have 1 copper to 1 bromide, and so our molecular formula would be CuBr. Again, the key is to make sure the total charge of your compound is 0. So +1 -1 here, and +2 -1, so we have 2 chlorides in the top example. Now we have another case of our ionically named compounds of when we're using what's known as polyatomic ions. So there are some ions that don't just come straight from the periodic table, but are actually a collection of covalently bonded atoms together that overall have a charge. So we need to be familiar with some of these polyatomic ions, and we can see here, so for example, ammonium, NH4, is all covalently bonded together, but collectively this unit has a charge of +1. We can look at something like sulfate, SO4 2-, again, comes as 1 unit collectively, but overall has a 2- charge. So in this case, we're asked to give the formula of this ionically bonded compound, ammonium hydroxide. So we have a positively charged polyatomic and a negatively charged polyatomic. And if we look these up, ammonium would be NH4 +1. Hydroxide is OH with a -1 charge. So our formula is NH4OH. Again, a +1 and a -1, so the charges balance out. So that was our naming system for ionically bonded compounds. So now we can quickly go over the naming system for covalently bonded compounds. And we're going to look at a simple case where we have binary covalent, so just 2 different types of elements present in our covalently bonded compounds. This is going to be similar to ionic, where we're going to first name the element in the formula using the first element using its elemental name, and the second element in the formula we're going to treat it as if it was an anion by ending with the "ide" suffix, the IDE. But here, because we're not balancing out a charge like our ionic compound, we have to denote how many of each type of atom are present. And we're going to do that by using a prefix system. So the prefix system we're going to use, we're going to see, here's our prefix system for the numbers. We have mono if there's 1, di if there's 2 of the type, tri if there's 3 of the type, and so on. The one exception is the prefix mono we won't use if it's for the first element in the formula. That'll just be left off. So for example, if we were given the formula N2O, so we have 2 nitrogens and 1 oxygen. If we wanted to write the formula name of this, we have 2 nitrogens, so we'd start off in saying di-nitrogen, and we have 1 oxygen, so we'd have to do monoxide. So di-nitrogen monoxide. All right, and notice the space between the 2 words for our two elements. So here would be the name of our compound. We could work in the other direction as well, and we could be starting off given an elemental name or compound name. So in this case, carbon disulfide. And so in this case, we're starting off with carbon. So we'd start by writing the chemical symbol for carbon. And there's no prefix, so we know there must be one of those. And sulfide, so that's sulfur, and two of them. And so we'd end up with CS2 for our naming system. The last type of our naming nomenclature we want to go over is a system for naming binary acids that you will see sometimes and we'll see later in the semester. Binary acids have a slightly different naming system, and in general, our binary acids are going to be when we have a hydrogen bound to a halogen. So hydrogen with our group 17 elements, we're going to name them slightly different, and we're going to name those by adding the prefix hydro, and then we're going to add the name of the element, but instead of adding "ide" at the end, we're going to add "ic." And so what we'd have here for HCl would be hydrochloric, and then we'll finish off with acid, right? And that would be true for any H halogen. So that's HF, HCl, HBr, HI, etc. So that ends our mini lecture on naming simple compounds. Thank you.